In this video, we have two tasks. We're going to investigate the distribution of sample means by figuring out exactly what is this thing. Secondly, we're going to look at one of its characteristics, or two of its characteristics, which are that it's normally distributed and it has a mean equal to the original population mean. Enjoy. Note the URL here at the top. This is the website from which I'm getting this sampling demonstration. This is the original population distribution. It can be normal, or we can start with a skewed distribution. It doesn't really matter. Let's start with a normal one. This here is going to be our sample data. So you're taking a sample from a population, and we're going to take a sample of size. Let's do 5. And here's a demonstration of a sample of size 5. We just click on animated to get one sample. 2, 3, 4, 5. So it took 5 individuals from this population, and the blue is the calculation of the mean. We can do that again, and again, and again, and again. And every time we do it, we get, in this area here, we get a sample mean, a blue block that drops down. So we're going to get more and more and more as we keep taking more and more samples of size 5. Let's do a jump ahead to do 100,000 samples of size 5. What do we get? We get a distribution of sample means close to what's predicted, because the center of the original distribution is here, and the center of the distribution of sample means is also in the same area. So if we look at the original distribution, population mean is 16. The distribution of sample means, mean of the sample means, is also 16, which is as predicted. Let's do the same thing let's clear it and do that for a skewed distribution. So in a skewed distribution, we know that the mean is going to be larger than the standard deviation, and that's verified here. So it's pulled to the right here because it's skewed right. Now what happens if we take samples? Same thing. We're going to get values from all over the distribution, randomly chosen. And let's jump ahead to sample of 100,000 and look at that. We get again something that's fairly close to normally distributed, and our sample mean, our population mean, which is 8, and our mean of the distribution of sample means is also very close. Well, 8.08 and 8.09. Thank you for watching. Go to the site yourself and play around.